All right, let's move on to number 18. The question states you've got these 4 chips, all right, with a single digit written on each, and you're going to draw the chips at random without replacement and placed in the order in which they're drawn from right to left to form a 2-digit number. What is the probability that the 2-digit number is a prime number? So you've got these 4 chips, you're only going to draw 2, and you're going to, it's going to be a 2-digit number, and the question is, what is the probability that that number is prime? So this is a probability question. And in probability, we always start with the total possibilities. And that is the denominator. And then we figure out the sort of, I don't know how to say it, not correct, but the yeah, well, let's go with the correct choice in this case. Correct choice of a of it being a prime number. So we actually have these 2 switched. So let's make this a little more clear. Zoop. That way, it's the denominator, right? And the total possibilities here, right? And we'll call that T. The total possibility of 2-digit numbers formed by those 4 items would be, what is it, 1, 2, 3, 7, right? The total possibility of those would be the total number of different 2-digit numbers you could get. So you could have, and that set is 12, 13, 17, 21, 23, 27, 31, 32, 37, okay, 71, 72, 73. So sort of the number of elements in the set, 12, so we've got three different 2-digit numbers for those 4 different coins, so we'd have 12 as our total possibilities, and then we see that the primes, okay, are a subset of the total, and the primes are, well, obviously anything ending in 2 is not, so and we'll cross those out. Let's actually rewrite it, right? And then we'll cross out all of the ones that are not prime. Cross them out in red. So 12 is not prime. 12 is not prime because it's 6 times 2. 13 and 17 are prime. 21 is not prime because it's got the factors 3 times 7. 23 is prime. 27 is not prime. 9 times 3. 31 is prime. 32 is not prime. 16 times 2. 37 is prime. 71 is prime. 72 is not prime. And 73, we'll clean up that 3 a little bit. Okay. 73 is prime. And so the number of elements that are prime that can be made up of those 2 coins, or those 2 of those chips, would be 13, 17, so 1, right? 1, 2, 3, 4, 5, 6, 7. So 1. So we've got check, 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 and that would be a cross for that one, and check, check. So we've got 7. So the probability of finding a prime number by pulling out 2 random chips would be 7 over 12. Here's the challenge. What about 3 chips pulled? Okay, what are the chances of finding a prime number if you pull 3 chips? It's actually not much of a challenge now that I think about it. But it'd be fun for you to do.